Hey guys, welcome. My name is Jackson, and in this video we are continuing on with the building system series. This is part 3, and today this is what we're going to be building. Oh my god, there's all this shit that I left here. Basically all the save game stuff is done in the previous tutorial, but in this one we've tidied up our building, so this is a lot smoother now. We had a little bit of a choppy movement before. You can see it's red if it's on a surface that is too steep for it to be placed. If it's not on a flat surface, you can't place objects on walls. We've got that shiny material, and we've got, yeah, it colliding with walls like that. You're not able to place there. So you can hear me clicking. Yeah, forbidden. So yeah, we're just basically tidying up a heap of shit today. Yep. So inside of the building character, the BP building character, we're going to be editing the location stuff here first. So I'm just going to butcher all of this for a moment. So I might try and get rid of this, and I'm going to try and tidy all this up into just one get location node. So basically this is the line trace from the follow camera, and this is hitting somewhere, and it's got this caster character node up here. I want to see if I can compress this into one function. So I might collapse that like that and call this get location, or get simulation location, maybe. Get simulation location. Yeah, like that. Simulation location. It sounds so funny, doesn't it? So this is going to be line trace hit point, line trace hit location, and then this is going to be simulation location, and then that's going to go up into there, and that's going to be the location that we set the simulation to. So inside of this we're going to do some editing inside of here. So if it's a character, we're going to add this here, which is the half height of the character. So that'll be the location for characters. If it's not a character, sorry, we don't need that. If it's not a character, then we actually just feed the line trace location straight into the output. So what we could probably do here is collapse this to another function and call this adjust hit location for characters, and just put that there like that. And then this will be hit location, and then the output is going to be adjusted hit location. This is like functions in functions in functions. So that's going like that. And if it's not a character, so if this cast fails, then we're going to have a return node down here which won't do this whole bit here, which is adjust height for character capsule. That's what that's doing. So the hit location can just go straight into that if it's not a character. Okay. So that's fine. That's all well and good. So nothing's really changed now. We haven't added anything new yet. We've just reorganized this. So now, if we've got that, now we want to look at snapping. So what we could do is we could break. Let's break this vector. And let's snap to grid the X and the Y, but not the Z. And then we will make a new vector down here. So we don't want to snap to the Z because otherwise you might get shit floating up in the air. We're really interested in snapping the X and the Y so that you can get things placed nice and neatly next to each other. Now the grid size, let's promote this to a variable and call this snapping grid size, and put that into both of those. And we might have a select node here, select vector, and the boolean here is going to be snapping enabled ? And these two are both going to be public variables. So click the little eyeball down there, F7 to save and compile, or Control Shift S to save. Now snapping enabled, if that's set to true, then it's going to be A, which means we'll use that. If we don't want snapping, then we're just going to feed that hit location straight into there. So that can all go up there. And then this here, all this here is going to be snapping ? And this is going to be adjust height for characters, which it already says in the function, but like, I just like to comment shit just so you can see what it's doing. When you go back and you look at it, you can tell at a glance. So if we put snapping enabled to true, for now, and the snapping size to be like 100 units. And we jump in, and we've got all this shit everywhere, which actually I might just delete, so I'll show you how to do that. I think I showed you in the last video, but we're going to show you again. So Unreal Projects, building system tutorial. This is the name of the project. Go into saved games. This is a separate map, and this is the map that we're on. I'm just going to delete them both. So now if I press play, we've got no save data. I press B, you can see that the table is snapping. Okay, and I can change that for all of these. Yeah, see, it's nice how it's snapping right to those it's right to the grid on the floor, because that's obviously 100 units apart on the material. That's really cool, and you can rotate that like that as well. And it also works up here on these surfaces as well. It'll always be flush to the ground. Look at that. So that's nice and neat, right? How cool is that? I like that a lot. That tickles my OCD. Okay, so that's the snapping done. So the other problem that we have, so if we enter building mode, see, we can place tables up on walls, which I'm not gonna lie, that's actually pretty cool. But in case you wanted to get rid of that, by the way, this is all saved now, so I'm stuck with this until I delete it again. You could you could write your name in the wall. That's rad. But in case you didn't want to do that, you can create an option so that you don't let the player place things up on walls. So how the flip are we going to do this? Okay, so the next thing that we're going to do is update the simulation material to show if it's a valid building location or not. So yeah, if it's up on the walls, no, or if it's colliding with something like this, then you can't build there, obviously. So the way that we're going to do that is we're going to need 2 new materials. Fast forward this bit if you know how to do basic emissive materials, but I'm just going to have m_emissive, 3 left click for a 3 vector, m left click for a multiply, bup emissive color, make this a unlit material. This is going to be blue, and 1 left click for a constant, and this can be like 5 or something. And then we've got a basic emissive material like that. Yeah, I mean, that's pretty rad. So now if I create a material instance and call this emissive blue and emissive red, open up the red one, we need to go back into the parent and right click, convert this to a parameter, and just call this color. Blah 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 blah. I feel like I'm talking like a robot. Close that, and then just click this, change the color red. Red. I kind of like that pink actually. That's kind of sick. Yeah, let's do that. I like that. Yeah. So now, inside of our building character, we're gonna need a new function. Or maybe we can do it in here. No, let's create a new function which will be called update or set valid building state. Or set building state validity, maybe. Set simulation building state validity. So we're going to call this whenever the building validity changes. So for example, or maybe let's just do it. So let's grab this building sim actor reference. So this is a reference to the simulation, and we're going to get components by class. We'll get all of the static meshes, and then we're going to use a for each loop, and for each, oh actually this might be a pain in the ass. Actually no, it won't. This will be fine. We're going to set the materials of all of those, and the new material is going to be, well, we could just probably promote this to a variable and call this m underscore valid sim, for valid simulation. Now can I put in our emissive blue? Yeah, cool. So actually this is going to be a select node, and This is going to be a boolean, which is going to be it's not going to be a variable down there, so we can get rid of that. It's going to be a variable being fed in from here. So let's put that into there so we get the input pin. Then I can break that, and then I can set this to a... No, I don't need to set that to a local variable because it's already a local variable. So if I rename this and call this new building validity, like that, and that's being an input, I can go off this and say new building validity, and I've got access to that down there. So now mValidSim, if the building is valid, then that can go into there. If it's not, let's duplicate this and then call this one inValidSim. And then this one can be the red one, so emissive red or dank pink or whatever you want to call that. And then that goes into there, and then all of this is updating material of simulation. Okay, but what we also need to do is we do need to promote this to a variable and call this is building sim lock valid. Is building sim location valid? And we're going to actually save that because that's going to be used to determine whether or not we can build later. Store new building sim validity. Okay. Okay. So what are we going to do here? So let's do the walls first. So let's make it so that we can't place it on the walls. First, when we refresh this building simulation, destroying the old sim and we're spawning a new sim here, we've spawned it. Now we need to call this new function and set the validity to true, I suppose. We'll set that to true. We'll just assume that it's valid at the start. Or maybe let's assume that it's invalid at the start, and then the next tick down here we can determine if it's actually colliding or whatever. So, okay, line trace by follow cam. If there is a hit, if there's a hit, then we can go on. If there's not a hit, then it's instantly invalid. So, is building sim location, oops, not that one. Instantly, if there's not a hit, then it's not valid. If there is a hit, then we need to check, is the impact normal equal to positive Z, like that? Is it a flat surface, basically? Maybe with some degree of tolerance, so maybe like 0.1. Is it a flat surface? If it is a flat surface, then it's valid. If it's not, then it's invalid, okay? So that's how we do that, and then that can go into there, and that should be fine. This isn't too good for the performance at the moment, although it's probably not too intense, but basically every 60 times a second, we're going to be setting this material like that. But what we can do is we could skip that if this hasn't changed, I suppose, or something. But anyway, let's jump in. B. Okay, that's valid. This is not valid, all right? But it still let me place because we haven't set up that functionality yet. This is valid apparently because this is actually not steep enough to make it invalid, whereas this one here is clearly too steep. Now I can place it on top like that, and we can still, no, we can't place on the wall now, look at that, because the impact normal of this hit is not straight up, it's not a positive Z. But we can still place because we haven't put that functionality in, but we can place it on physics objects as well, so that's pretty dope. And yeah, same with all of these, except for you, because you aren't a static mesh. This is a skeletal mesh. So what you'd want to do for the skeletal mesh is inside of here, you'd have another for loop. You'd do this exact same thing down here, but you'd use skeletal mesh down here. And you'd set the materials of that skeletal mesh. So we'll do that later, or that can be your homework or like whatever. You're gonna work like that? Yeah. That can be your homework maybe, if you want. You don't even have to. Okay. So now we need to disable the actual building if this validity is wrong. So now down here, whenever you input the left mouse button, let's literally just drag this in, control drag, B and left click for a branch, and then is the building sim location valid? True, do that. If false, then don't build. It's as simple as that, right? So now I can build there, that's fine, but this is invalid. I'm clicking, can you hear me clicking? That's invalid, so you can't place on the walls now. So look, honestly, that's like pretty done, right? This rock doesn't actually have collision, so I can place them all on top of themselves like that. But what if I try to place... Okay, so I can't place this inside of there. But that's not because it's colliding. It's because the impact normal of the hit is invalid, I think. Or it's not perfectly Z. I don't really know. I don't really know what's going on exactly. But, oh my god, we've got so many actors running around right now. Yeah, rad. I'm going to pause and have a think about what to do next. So the last thing to do is to stop you from being able to spawn them on each other if they're colliding, I suppose. So like for example, if we had our rock and I wanted to spawn that right there, you can see that that's colliding with the wall. So I probably wouldn't want to be able to place it there. The first thing, I don't think this rock actually has collision, so I'm just going to open up that static mesh and just check. So if you go to collision up here, what happens if I just click that? I don't actually know how to view collision here. Okay, that's collision, right? Sure. What if I control B to browse? Yeah, so you can see now, usually there's a bit of yellow text in there somewhere if it doesn't have collision, but it must have collision, so that's fine. Actually, you know what we can do to test it? Let's just put you there. And can I run through it? No. Okay, so you've got collision now. And I can still place that in the wall when it's clearly colliding, so we don't want that. Or you do want that, you know, there's no hard and fast rules with game development. If you want to be able to do that, then you fucking do that, alright? Like, go for it, it doesn't matter. But let's say that you didn't want to do that. Let's go back into our building character. I might just close some of this shit up here because I've got a lot of stuff open. Now, what we want to do, we don't want the collision of the simulation to actually be on, because if you've got a simulation that's colliding with things, you can use that to push physics objects and shit around. We had that issue in the first video. So in refresh building simulation, we have this set actor enable collision set to false. We want to keep that, but we want to check if the simulation is actually colliding. So what we might do is before we set that collision to false, we could get actor bounds. Only colliding components, yes. Okay, and then the box extent. What if we promote that to a variable and call that current sim actor bounds, I guess, like that. And we'll save that and we'll use that to check for collisions in just a moment. So let's close down some of these tabs. I did get the origin, not the origin, the box extent. Yep, cool. So when we're doing all of this here, we're checking if it's on a wall, and then we're getting the simulation location, you know, if this is a character or whatever. Then I suppose what we want to do is we want to actually, we'll set the location, that's fine, but then we want to check if we can actually build there or not, or if it's colliding. So we could take this simulation location thing here, and we could go a box trace by channel. The starting location is the simulation location. The ending location is also the simulation location, but the half size of the box will be the actor bounds of the actor. And we can put that debug type for duration so that we can see it, or maybe let's put it on for 1 frame. And the actors to ignore, let's make that our simulation because we don't want it to collide with itself. And it'll also ignore the player. But maybe you don't want that. I don't know. Let's just leave that on. So this is going to be drawing a box now around our simulation. So if we jump in, see that box on the ground? It's colliding with the floor right now. Yeah, and see, you've got that happening for our character. Yeah, it works fine with the character actually. It's still colliding with the floor, so we're going to need to like reduce its size or something in a minute. But yeah, you can see we've got a box around this as well. Yeah, but it's always colliding. What we need to do is we probably need to get the origin back in the building sim thing. And probably save that as well. So we'll get current sim collision origin, and we'll save that too, I guess. Yeah, and now I guess what we'll do here is break both of these. The starting location of this trace is actually going to be the simulation location, add vector, add. We're going to add the origin. I'm assuming that's a local origin, I don't know. I guess we'll see. And then we're going to feed that into here. Yep. Let's try that. Now this is going to fuck up the character probably, but let's see what happens with the other ones. Oh, I can see the trace. It's like way over on the wall. Huh. So maybe, let me have a think about this, because I know how to do this, but I just need a moment to wrap my brain around it. Okay, so inside of the refresh building simulation function, if you look at this origin thing, it says the center of the actor in world space. We don't want this in world space. We want this origin in local space. So I might rename this current sim collision origin local. Maybe local space, so you don't confuse that with a local variable. And I believe we just want to minus or subtract the world location of this, I guess. And that'll be the location in local space. So if we get the actor location of U and subtract that off of the world location of the origin of the collision, then this should return the relative location or something like that. Let's see. Oh my god, it actually worked. Would you believe it? And it's red. The collision around it is red, which means it's not hitting. It's hitting with the character still. Oh, it didn't actually it didn't ruin the character. That's interesting. Working fine with you. Working fine with you as well. Can place that rock anywhere. It seems that this one doesn't like being placed. Oh no. It looks like it's flashing green occasionally. Yeah, I don't know. Oh, I can place it on top of itself. Oh, that's because we haven't updated the validity rules based on this new box collision yet. But you can see that the box around it is working correctly. So if I were to put this up into the wall, you can see that the box is green, which means it's colliding. Where it's red here, it's not colliding, okay? Yeah. Yeah, well, that character's colliding there for some reason, but that's fine. We'll figure that out in a minute. I can't believe this is actually working. This is freaking, it's a miracle. Okay, so now we're doing our box trace over here. God, this is a big tangly mess, isn't it? Let's break this hit. If there's a hit, well, actually, we can just set simulation building state validity right here, right? Yeah, we could go not bool in there and just plug that in. So if there is a hit, then it's not valid. If there's not a hit, then it's not valid. Just trust me, it'll work. But there's probably a smarter way to do this. Like you could probably drag this over here. I'm not going to though. Let's just leave this how it is. Let's check if this works. I might just delete my save game really quick because I've got shit absolutely everywhere. Okay. Dropping in. Yeah, cool. That's working. And then I'm not allowed to place it there. And if I click, nothing being placed. Now we can rotate it just fine. That's not breaking anything. Now I'm not allowed to place you for some reason because you're colliding. You are also sort of colliding. Sometimes, by the look of it. Yeah. I'm not sure why that is. I think the trace might be colliding with the floor somehow. Sometimes. Yeah, and what about our rock? Okay, so you're invalid there because you're colliding. Okay, so the collision is definitely going through the floor with him. Yeah. So there's a couple of things that you could do to fix that up. I mean, look, this is basically the video done. I mean, this is sort of, those are the core things. You can tweak these a little bit. So maybe what we'll do here is maybe we can subtract, I don't know, like 10 off of these or something, or maybe like 20 off the Z, just so that the bounds of it isn't actually like super aggressive. So you can see that it's like smaller for the table now. That feels like a bit of a cheat, but like, I mean, look, that's gonna do the job, right? It's still not working with this rock though, because the rock bottom is still going through the floor. So maybe there's a way to just make sure that it's not colliding with the floor. So maybe what we could do actually is we could probably break this hit down here, and we could do what we did back here, get this floor thingo, and we can check if the impact normal is equal to the floor. If the box trace channel is actually hitting the floor, then this is actually fine. So what we can do is you can put that branch in there. Let's just reconnect that bounds up there again. If the box trace is hitting the floor, let's just put this like this, and I might just comment this: is box trace colliding with floor? Or even before that, let's be really clear about how we do this. So let's have a branch here. Is there a collision? True, then go ahead. If this is false, then we can just go ahead like this and say, if there's no collision, then it's a valid location, okay? End of story. Actually, no, not true, because there still could be this situation over here, which we'll deal with in just a moment. But assuming that everything else checks out, if there's no collision, then this is a valid location to spawn. If there is a collision, then is it with the floor? If it's with the floor, then it's a valid location. If it's not with the floor and it's colliding with something else, then it's not a valid location. Okay, so that's how we set that up. So let's have a quick look at that, shall we? Let's see how that goes. So you're not colliding with the floor. You're still colliding with something. You're still colliding with something. And you're also still colliding with something. Lame. Okay, let me think about this and I'll come back. Okay, so I've got one more idea that I'm going to try, and if this doesn't work, then I'm still going to include it in the video. But just to basically give you an idea about how to think about, you know, how you could get this system to work in the way that you want it, because there's going to be a few details here and there that are going to be up to you as a game developer to, you know, do what you want with, and, you know, fiddle with it so that it works for you. But basically the way that I would do this collision situation, I've just disconnected everything from this box trace, and I've got a new idea. So what I'm going to try and do is do, like, instead of doing the start and the end location being the same location and then have the half size be the bounds of the actor, I'm going to try and start at the feet, scan up to the top, and have the half size be like a 2D plane. Yeah, that's the idea. So what I'm going to do is I'm going to take the simulation location, which is on the ground, because this is where it's hit, or it'll be in the center if it's a character, which might actually be a headache in a minute, but let's just see. You got to pick your battles with these things sometimes. Like, maybe it's not that necessary to spawn characters perfectly so that they look nice. That could be a detail that I get to later. This is on the ground, so that's going to be the start. And you know what? I might actually even just add a vector or add a vector of like 10 units, okay? So it's 10 units off the ground, just so it definitely doesn't collide with the floor, or maybe even 1 unit, okay? And then the end is going to be the simulation location, adding a vector which will be the bounds, I suppose, but just the Z. Just the Z of the bounds. Oops, we don't want to watch it. We want to stop watching it, split, and then just add the Z of the bounds. So now that we're scanning up, and then the half size is going to be, can just be 1 on the Z, and maybe we can use the bounds on the X and the bounds on the Y. And then that should trace upwards, theoretically. Let's see. Okay. That's still colliding with something. Oh, no, it's not. No, it's fine. Yeah. It flashes green every now and again, and I'm not really sure why. Like there. Like, why is that green? It might be because my trace is hitting the simulation, actually. That could be a weird little thing that I need to fix. But this seems to be working now, except it's not scanning all the way up. So maybe the issue for that is because this is only a half size. So I need to actually multiply this by a float. And then make that 2. I guess. I don't know. Yeah, so that looks better, actually. Look at that. Yeah. Yeah, so that's fine. That's placing on there. This one won't place on here because it's too steep. You can't place on the walls because the normal is not vertical. And then, yeah, you can place on the ground. Now, the character's gone all messed up because I'm doing the trace from the center of the character. We need to do another exception for the characters where it does the trace from the feet if you want the character to be perfect. Or you could just use this collision, you know? Like, that's a pretty fine collision if you ask me. And then, yeah, we got these guys that are spawning just fine. And then the rock, if we put that up against the wall. Why is that? It says it's colliding, but it's not updating the colors correctly. Oh, good heavens. I don't freaking know anymore, man. I think I might just leave this here. We're going to leave this a half-baked tutorial. Okay, so I think I figured out the last thing. So, just ignore that. Nothing to see there. Now that we've got this new collision scanning system, we don't actually need to check if this box trace is hitting the floor because it's never going to hit the floor because we're starting at the floor and then adding 1. So we can delete all of this like that. Now, is there a collision with the box trace? No, then it's valid. Yes, then it's not valid. So now if I turn my debug off for the box trace and we just look at this at face value, it's been a bit weird. See how it's colliding there? I'm not really sure why it won't let me place it there, but up on the walls, you can't place it on the walls. You aren't updating your material. You're being a little bit odd as well, but you definitely can't place on the walls, which is good. That's what we want. Yep. So when it's colliding with the walls, yeah, that's a no-go. But there is just this issue of like it flashing like this. So I'm just going to figure that out. So I literally think that the flashing thing, just ignore this. I literally think that the flashing thing is just it colliding with the floor. So if I were to add like a 5 onto this instead of a 1 perhaps, maybe that's enough to resolve it. Yeah, so it's not actually flashing anymore. So all these are valid points. They're not valid if you're colliding with the same one. Now the rock is fine to place. It will not let you place it up against the wall. It will not let you place it on a wall. It'll let you place it there. Not there. There. Yep, that's fine. On a table. Yep, sure. Yeah. So you know what? I think I'm pretty happy with this, the way that this is looking. So I think I might cut this here, and I'm just gonna sit here for a moment and watch these AI run around in this confusing world that I've somehow managed to create. One more thing actually, is just the FPS of the game. So if you're in here, because these are moving at 60 FPS, or they're updating the location at 60 FPS because of this, you need the game to actually run at 60 FPS. So maybe inside the game mode is probably a good spot to put that. I don't know, or your game instance, or. But basically, what you'll want to do. What you'll want to do to get it running smoothly is get game user settings, just so you get the simulations updating consistently. And you'll say set frame rate limit, and we'll set that to 60. Or you could even say, oops, you could do what we did earlier. Sorry, no, we did that in a previous video. Let's just set that to 60. But basically, I was going to say you could use a get function in a function library, and then you want to say apply settings. Don't forget to apply settings, otherwise this doesn't work. So this is set FPS limit. Yeah, you got to apply those settings. You can't just set the limit and forget about it. So now we're at 60 FPS. Yeah, we've got these moving. That already looks smoother, actually. It's less jittery. Now I'm going to turn that debug thing off. So back in the building character, draw the debug type, turn that off. And also, what I might quickly do is, do I have an input for R? No, I don't. So I'm going to go input key R. No idea why I chose R or why I'm spending so long searching for this when any other key would do just as well, but I'm going to use R. And we're going to do exactly what we did up here with this flip-flop thing. Except that's not going to be a branch. And we're just going to have snapping enabled, like this. And we're going to be able to toggle that on and off. So by default, let's have it off. And just call this R snapping. Okay. So now, press B for build. You can look how smooth that is. So in the first video, this was really hideous and like choppy, and it was because the frame rate of this simulation updating was different to the frame rate of the game. So now if I press R, we've got the snapping back on, and you could use the mouse wheel as well to change the snapping size if you wanted. You just need to add some functionality for that. But I think that's basically it, guys. I'm going to leave this tutorial here. I think there might be some more stuff that I'll do for this in the future, but I'm not sure. I feel like we've covered a lot of ground here. I'm probably going to put this on the marketplace as well. I don't know. I guess we'll see, huh? But if you've got any questions about any of this, drop me a comment, and I hope this was helpful. If you liked it, drop me a comment as well. I like hearing feedback. But yeah, hope this was helpful, and I will see you in the next one. Peace out.